Hello students, in continuation with the chapter units and measurements, you know that I introduced what dimensions. Already I have talked about the dimensions, that what are dimensions. Again I am repeating that what are dimensions. Now we know that, again I am writing here, the powers to which fundamental quantities like mass, length, time, fundamental quantities must be raised in order to express the given physical quantity. Given physical quantity are called its dimensions. So we are talking about the dimensions. And already I gave you an example. And I said that for the mass is m, say we are talking about the mass, the dimension is m. For length, it is L, the dimensional formula. For time, it is T. Though we can write in complete form of dimensional formula is that M, L0, T0. Here we can write M0, L, T0. Here you can write M0, L0 and T. Their powers are, say, M power A, B, C. These are the dimensions. A, B and C are dimensions. So we'll just discuss about the dimensional formula. I gave you an example. Again, I am giving an example. Say there is work. Now work is force into what? Displacement. Now if I ask you what is force, you directly don't know what is force. It is mass into acceleration into displacement. What is mass? It is m. What is acceleration? It is velocity upon time. What is displacement? Dimension L. What is velocity? Displacement upon time. So it will be LT minus 1, and again there is T. So it will be what? If you see m L square, and then it will be T minus 2. See here. So how you calculated it? You know the formula, you can find out the dimensions. So today we will discuss some dimensions related with the physical quantities. Now I am writing here 10 physical quantities one by one, and those quantities, you know, first is density. Now, I think all of you know density is mass per unit volume. So can you write mass per unit volume is what? M. Volume is what? L cube. So directly it can be ml minus 3. Okay. Second, if I ask you what is the dimension of power. Now I think most of you know power is work upon time, and work you have already calculated is ml square T minus 2, and what is time is what? T. So finally we can write ml square T minus 3. The third is, if I ask you what is the dimension of what? Say time period. Now time period is time, nothing in that. So time period is, it will be T. So we know that the dimension is T. Then if I ask you wavelength, now wavelength, length is lambda, and then it will be what? L. Then if I ask you frequency, I think all of you know frequency is 1 upon time period. So can we write? Yes, T minus 1. So we know that how we are going to write the dimensions of these quantities. But if someone asks you what is what about the charge. Now charge, though you have gone through it in class 10th and you will go through it in class 12th, but charge is Q. And I think all of you remember charge is IT. So what is I? Current into time. So current is A and time is T. So the dimension will be what? AT. In the same way, if I ask you what should be the dimension of, say, force you have done, there's a quantity that which we say is acceleration due to gravity. Now, acceleration due to gravity. So, acceleration due to gravity is small g, and you know that g is an acceleration. So, can we write directly Lt minus 2? If I ask you what is the dimension of weight, now weight is what? mg. So, can we write m? What is g? Lt minus 2. So, it will be what? mlt minus 2. In this way, if I ask you what about the potential energy, now I think all of you know, because I am talking about those quantities which you know is what? mgh. What is m? What is g? Lt minus 2. What is h? Height L. So solve it. You will get what? ml square t minus 2. And then 10th, if I ask you what about, say, the you have gone through the quantity, say, relative density. Now if I ask you what is relative density, now relative density is what density of body upon what density of water. But then dimension will be ml minus 3, ml minus 3, because we know the density. So it becomes what? Dimensionless. So what we got? We have done 10 quantities. 5 are this: density, power, time, period, wavelength, frequency. Another 5, all these quantities which we have written the dimensional formula, we know them. But you see very interesting thing that the potential energy is here, and the work, you know that earlier, has same quantity, ml square t minus 2, ml square t minus 2. And another quantity, the relative density, has no dimensions. So certainly we have to discuss about what are the dimensions in detail. These are the quantities which are related, which you know, but there are some, I'm writing now some quantities which are in class 11th for the dimensional formulas. So dimensional formula for some quantity you may be knowing or not, but I am going to explain you that how we write the dimensions. But remember one thing, that these are the quantities which we will go through in the later on in the chapter, but just we have to write their dimension. So we should know their the formula. Now one is the impulse. Now I think some of you may be knowing impulse is what? Change in momentum. It is change in momentum. So or impulse is force into time. So if I ask you what about the force is mlt minus 2. Okay, mass into action t. So it will be mlt minus what? 1. So it is again of the momentum. Then if I ask you what about the have you heard about the torque? Now torque is a new thing. It will come in rotational motion. But the formula for the torque is force into what? Displacement. This is the general formula. Now force is what? Again, you know, it is mlt minus 2. Okay, and displacement is L. Now ml square what? T minus 2. Now see here, this is torque, is again its dimensions are near to potential energy to the work, but torque doesn't mean work. Work is different. So we'll go through all these things, but right now we are writing only the dimension on the basis of their formula. Then there's another quantity which will come in class 11th is surface tension. It will come in fluids, but the formula for surface tension is force per unit length. So again I am talking about the dimension only. What is force? mlt minus 2. What is length? It is L. So if I cut it, it becomes mt minus 2. Okay, then comes what? Spring constant. It will be the quantity related with what? Spring. And what is spring constant is K. K is force upon distance. This is spring constant. Now if you see what is force, mLT minus 2. What is distance, L? Do you know that it comes same? If I ask you a question, name two quantities which have same dimension, certainly surface tension and spring constant. Certainly torque and potential energy and work. So these are the quantities which are related. And then another quantity I am going to write it is what, say there is another quantity which is moment of inertia. Now moment of inertia will go through in rotational motion. It is written by I. I is mass into distance square. So if I ask you what will be the dimension m into what? L square. Simple. So these quantities will come in the chapters, but right now we are already, what we have said, we are talking about what? Only the dimension. If I ask you there's another word, energy density. Now energy density is also in fluids. And you know energy density is energy per unit volume. And energy is what? Potential energy, kinetic energy, ml square t minus 2. What is volume? Volume is what? It is L cube. So can you find out the energy density from here? Yes, certainly. Calculate it. It will be what? M L minus 1 t minus 2. Okay, in the same way, there is another quantity which we can say is, say, Planck constant. Now, Planck constant, some of you may be knowing, E equal to h nu. So, h is energy upon what nu? Energy upon what? Nu is what? Frequency. So if I ask you what is energy, again here it is written ml square t minus 2. What is frequency? T minus what? 1. So can we calculate it? Yes, ml square and it will be t minus 1. So, and in this way we can find out of say radius of gyration. Now there is another quantity which will come in class 11th. All these are related with radius of gyration is actually a distance. It is a length. So directly I am going to write is L. And then say if I ask you what will be the angular velocity. Angular velocity is also going to be in your syllabus. Angular velocity is say angle upon time, angular displacement upon time, angular displacement upon time. You know velocity, the rate of change of displacement here, angular displacement upon time. Angular displacement is what? It is theta, so it has no dimension. It is L to the power 0 t, so it will be simply t minus 1. So remember that this is angular displacement means angle. And then the last one I am talking about is, say, there is another quantity and it is what? You know this quantity, it is pressure. So pressure is force upon area. So can you find out the dimension? Yes. What is that? mLT minus 2. Area is what? L square. So if it goes L minus 1, T minus 2. So certainly these are the 10 quantities which will come in class 11th. 10 quantities which we discussed where earlier you have gone through in class what? 9th. Now what I said is that regarding the dimensions, you don't have to, know about all the quantities, what is tension, what is force. Just we are going to write the dimension later on. All these things will come in the chapter. What are their physical significance? But right now going with the applications based on the dimension, I am going to explain you one very important formula related with the one concept related with the dimension, and that is principle of what? Homogeneity. Principle of dimensional, we can write complete dimensional homogeneity. Now, what does it mean by principle of homogeneity? Dimension, we know mass, length, time, but principle of homogeneity means what? That same type of dimension can add and subtract. If I ask you what will be the dimension of L plus L, L plus L. Now you will say it will be 2L. But the dimension 2 is a constant, so dimension will be what? Only L. If I ask you T plus T, you will say, sir, 2T, but it is the dimensionally, it is only T. If I ask you what is M plus M, You will say, sir, 2m. So dimension is what? Only m. See, similarly, LT minus 1 plus LT minus 1 will give what? The dimension LT minus 1. 2 is a dimensionless. Similarly, if I say M3LQT minus 4 and plus M3LQT minus 4, what the resultant is going the same for the dimension. Okay, this is homogeneity. So homogeneity, you can't have LT minus 2 plus LT minus 3. No, this is wrong. This doesn't follow the homogeneity. So what is the principle? So principle is according to the principle, we can even write according to the principle, what? We can write it the like physical quantities can be added or subtracted. Okay, so this is the principle for what? Homogeneity, and we are going to apply this principle in what? Different applications, and I will show you how we apply. Got it? L plus L will have the dimension L, T plus T will have the dimension T, M plus M will have the dimension of M, and similarly, but you can't add 1 meter with 10 seconds. So we know that physical significance, there is no physical significance of this. Can we say anyone to add 3 kg with 50 meter? No. So see here how we are going to apply. So first application is going to come for the homogeneity, and before going to that, yes, application, we are going to application of what? Dimensions. So dimensional analysis. Okay, application of dimensional analysis, and first we are going to talk about is that how we are going to apply dimensional analysis. First of all, I will tell you something related with the dimension. One is that there are some quantities which are dimensional variables. First, so what does it mean by dimensional variable? Those physical quantity, okay, those physical quantities which have dimensions, okay, and varies, they are changing. So they are such are what? Dimensional variables. Now most of them we see that they are dimensional variables. So example, if I ask you what is displacement, I said dimensional variable, acceleration, force, etc. These are all dimensional variables because they have a dimension and they vary. But the second one, if I ask you what is the second one is dimensionless variable. Dimensionless variable. Now what is dimensionless variable? Simply those physical quantities, okay, those physical quantities which have what? Which have no dimensions, but they vary. Now can you tell me what are those? Yes, tell me. One is refractive index. It varies. One is your what? Relative density. So in this way, there are a number of quantities where we say that one, you will find that there is a word magnetic susceptibility. So you will find this in class 12. So these are, you can find out number of quantities. So, and in the same way, we have dimensional constant and dimensionless constant. If I ask you dimensional what? Dimensional constants. So there are some quantities, those physical quantities which act as constants and have dimensions. Now, first of all, the thing comes is gravitational constant. Okay. Planck's constant. Already Planck's constant I have written there. Now someone asked me that how you will find out gravitational constant. What is F? You remember G m1 m2 by r square? All of you remember it. You have gone through in class 9. What will be G? F r square by what? m1 m2. What is force? mlt minus 2. What is r square? L square. What is mass m1 m2? It will be m square. Can you calculate it? Yes, m minus 1 L cube t minus 2. So this is the way we are going to get. And the fourth quantity is what? Dimensionless. What? Dimensionless constant. So those physical quantities which act as what? Constants, but and have what? No dimensions. Now can you tell me? Yes. Example is that what? Pi. Now pi is 3.14. It's a constant, no dimension. Okay. Similarly, numbers, numerals, numbers 1, 2, 3 angles. So these are the dimensionless constant. So there are four things. One is dimensionless constant, dimensional constant, dimensional variables, dimensionless variable. So then we'll move on their applications. So go through all the dimensions, find out them, and you can see if you go through the NCERT book, you'll find it in 214 page that dimensions are written. You can go through it. Okay, and thank you. Regularly watch my videos.